Hello guys, for today's video, we're gonna talk about the chapter summaries. All in all, the chapter summaries of chapter 1 to 11. So, let's start with chapter 1. Explore the network. Exploring the network. We now stand at a critical turning point. Use the technology to extend our ability to communicate. The globalization of the internet has successful faster than anyone could have imagined. This manner in which social, commercial, political, and personal interaction occur is rapidly changing to keep up with the evolution of this global network in the next stage of our development. Innovation will use the internet as a starting point for their effort, creating new products and services specifically designed to take advantage of the network capabilities. As the developers push the limits of what is possible and capabilities of the interconnected networks that form the internet will play an increasing role in the success of these projects. So in this chapter, introduces the platform of data network upon which our social and business relationships increasingly depend. The material lays the groundwork for exploring the services, technologies, and issues encountered by the network professionals as they design, build, and maintain the modern network. Networks and the internet have changed the way communicate, learn, work, and even play. Networks come in all sizes. They can range from simple networks consisting of two computers to network connecting millions of devices. The internet is the largest network in existence. In fact, the term internet means a network of networks. The internet provides the services that enable us to connect and communicate with our families, friends, works, and interests. The network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which communication can occur. It is made up of network components, including the devices, intermediate devices, and network media. Network must be reliable. This means that the network must be fault tolerant, scalable, provide quality of service, and ensure security of the information and resources on the network. Network security is an integral part of computer networking, regardless of whether the network is limited to a home environment with a single connection to the internet or as a corporation with thousands of users. No single solution can protect the network with a variety of threats that exist. For this reason, security should be implemented in multiple layers, using more than one security solution. The network infrastructure can vary greatly in terms of size, numbers of users, and numbers of types and services that are supported. The network infrastructure must grow and adjust to support the way the network is used. The routing and switching platform is the boundary of any network infrastructure. This chapter focuses on networking as a primary platform for supporting communication. So next one is chapter 2. Configure a network operating system. Every computer requires an operating system to function, including computer-based network devices such as switches, routers, access points, and firewalls. These network devices can use an operating system called a network operating system. A network operating system enables device hardware to function and provide an interface for users to interact. In the CCNA course of study, students learn to configure both devices that connects the network and devices such as PCs and devices that connect networks together, intermediate devices like router and switches. Learning to configure the Cisco intra-network operating system, Cisco IOS on Cisco routers and switches is a large part of Cisco CCNA program of study. The Cisco Inter-Network Operating System, or iOS, is a generic term for the collection of network operating system used by Cisco networking devices. Cisco iOS is used for most Cisco devices, regardless of type or size. Cisco iOS is a term that encompasses a number of different operating systems, which runs on various networking devices. The technician can either command to configure or program the device to platform various networking functions. Cisco iOS routers and switches perform functions that networks professionals depend upon to make their network operate as expected. The service provided by the Cisco iOS are accessed using the command line interface CLI, which is accessed by either the console port, the aux port, or through SSH or Telnet. After connected to the CLI, network technician can make configuration changes to Cisco iOS devices. The Cisco iOS is designed as model operating system, which means a network technician must navigate through various hierarchical modes of iOS. Each mode supports different iOS commands. Cisco iOS routers and switches support a similar model operating system, support similar command structure, and support many of the same commands. In addition, both devices have identical initial configuration steps when implementing them in a network. This chapter introduced the Cisco iOS is detailed in various modes of Cisco iOS and examined the basic command structure that is used to configure it. It also walked through the initial setting of a Cisco iOS switch device, including setting a name, limiting access to a device configuration, configuring banner messages, and saving the configuration. Chapter 3: Network Protocols and Communications. Network Protocol and Communications. More and more, it is networks that connect us. People communicate online from everywhere. Conversation in classrooms spill into instant message chat sessions. And online debates continue at school. New services are being developed daily to take advantage of the network. Rather than developing a unique and separate system for the delivery of each new service, the network industry as a whole has adopted a developmental framework that allows designers to understand current network platforms and maintain them. At the same time, this framework is used to facilitate the development of new technologies to support future communication needs and technology enhancement. Central to this development framework is the use of generally accepted models that describe network rules and function. Data network are system of end devices, intermediary devices, and the media connecting them. For communication to occur, these devices must know how to communicate. These devices must comply with communication rules and protocols. TCP/IP is an example of protocol suite. Most protocols are created by standard organizations such as IETF or IEEE. The Institute of Electrical Electronics Engineering is a professional organization for those in the electrical engineering and electronic fields. ISO, the International Organization for Standardization, is the world's largest developer of international standards for a wide variety of products and services. The most widely used network models are the OSI and TCP/IP models. Associating the protocols that set the rules of data communication with the different layers of these models is useful in determining which device and services are applied to specific points as this data passes across local area network and wide area networks. Data that passes down the stack of the OSI model is segmented into pieces and encapsulated with address and other labels. The process of reversed as the pieces are decapsulated and passed down the destination protocol stack. The OSI model describes the processes of encoding, formatting, segmenting, and encapsulating data for transmission over the network. The TCP/IP model protocols suite is an open standard protocol that has been endorsed by the networking industry and ratified or approved by a standard organization. The Internet Protocol Suite is a suite of protocols required by transmitting and receiving information using the Internet. Protocol Data Units or PDUs are named according to the protocols of the TCP/IP suite, data segment, packets, frame, and bits. Applying models allow individuals, companies, and trade associations to analyze current network and plan to network in the future. So, next one is chapter 4, or consisting of network access. The TCP/IP network access layer is the equivalent of the OSI data link layer, or layer 2, and the physical layer, or layer 1. The OSI physical layer provides the means to transport the bit that makes up the data link frame layer across the network media. The physical layer components are the electronic hardware devices, media, and other connections that transmit and carry the signal to represent the bits. Hardware components such as network adapters, or NIC, interfaces and connectors, cable material, and cable designs are all specified in standard associated with the physical layer. The physical layer standard addresses the three functional areas: physical components, frame encoding technique, and signaling method. Using the proper media is an important part of network communication. Without the proper physical connection, either wired or wireless communication between two devices will not occur. Wired communication consists of copper media and fiber cable. There are three main types of copper media used in networking: unshielded twisted pair, or UTP, and shielded twisted pair, or STP, and coaxial cable, or known as coax. UTP cabling is the most common copper networking media. Optical fiber cable has become very popular with the interconnecting infrastructure network devices. It permits the transmission of data over longer distances and at a higher bandwidth or data rates than any other networking medium. Unlike copper wires, fiber optic cable can transmit signal with less attenuation and is completely immune to EMI and RFI. Wireless media carry electromagnetic signal that represent the binary digits of data communication using radio or microwave frequencies. The number of wireless-enabled devices continues to increase. For this reason, wireless has become the medium of choice for home networks and is quickly gaining in popularity. Enterprises network, the data or link layer, handles the exchange of frame between nodes over the physical network media. It allows the upper layer to access the media and control how data is placed and received on the media. Chapter 5: Ethernet. Ethernet is the most widely used LAN, local area network technology today. This family of networking technologies that we defined in the IEEE 8.02.2 and 8.02.3 standards. Ethernet standards define both the Layer 2 protocols and Layer 1 technologies. For the Layer 2 protocols, as with the all 0.02 IEEE standards, Ethernet relies on two separate sublayers of the data link layer to cooperate: the logical link control, or LLC, and the MAC sublayer. At the data link layer, the frame structure is nearly identical for all bandwidths of Ethernet. The Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message without message being sent. All the data link layer, the frame structure is nearly There are two styles of Ethernet framing: IEEE 0.02.3 Ethernet standards and the DICS Ethernet standard, which is now referred to Ethernet 2. The most significant difference between the two standards is the addition of the frame delimiter or SFD and the change of the type field to a length field in the 8.02.3. Ethernet 2 is the Ethernet frame format used in TCP/IP networks as an implementation of IEEE 8.802.2 by 23 by 3 prefix standards. The Ethernet frame provides MAC addressing and error checking. Chapter 6 Network Layer. The network layer or SI layer 3 provides services to allow devices to exchange data across the network. To accomplish the end-to-end transport, the network layer uses four basic processes: IP addressing to end devices, encapsulation, routing, and decapsulation. The Internet is largely based in IPv4, which is still the most widely used network layer protocol. An IP version 4 packet contains the IP header in the payload. However, IP version 4 has the limited number of unique public IP addresses available. This led to the development of IP version 6 or IPv6. The IP version 6 simplified header over several advantages over IPv4, including better routing efficiency, simplified extension header, and capability for per-flowing processing. Plus, IP version 6 addresses are based on 128-bit hierarchical addressing as opposed to IP version 4 with 32 bits. This dramatically increased the number of available IP addresses. In addition to hierarchical addressing, the network layer is also responsible for routing. Hosts require a local routing table to ensure that packets are directed to the correct destination network. The local table of the host typically contains the direct connection and local network route and the local default route. The local default route is the route to the default gateway. So next. Chapter 7 IP addressing. IP addresses are hierarchical with network, subnetwork, and host portion. An IP address can represent a complete network, a specific host, or a broadcast address of the network. Understanding binary notation is important when determining if two hosts are in the same network. The bits within the network portion or IP addresses must be identical to all devices that reside in the same network. The subnet mask or prefix is issued to determine the IP address must be identical, assigned statistically and dynamically. DHCP enables the automatic assignment of addressing information such as IP address, subnet mask, default gateway, and other configuration information. IP version 4 host can communicate one of the three different ways out: unicast, broadcast, and multicast. Also, blocks of addressing that are used in networks that require limited or no internet access are called private addresses. The private IP version 4 address blocks are 10.0.0.0 by 8 prefix, 172.16.0.0 by 12, and 192.168.0.0 by 16. The depletion of IP version 4 address space is the motivation factor for moving to IP version 6. Each IPv6 address 128 bits versus the 32 bits in the IPv4 address. IPv6 does not use the dotted decimal subnet mask notation. The prefix length is used to indicate the network portion of the IPv6 address using the following format: IPv6 address prefix / prefix length. Chapter 8 Subnetting IP Networks. The process of subnetting a network by dividing it into multiple smaller network slices is called subnetting. Every network address has a valid range of host address. All devices attached to the same network will have an IP version for a host address. For the network, that common subnet mask or network prefix. Traffic can be forwarded between hosts directly if they are on the same subnet. Traffic cannot be forwarded between subnets without the use of a router. To determine the traffic, local or remote, the router uses the subnet mask. The prefix and the subnet mask are different ways of representing the same thing, the network portion of the address. IP version for subnets are created by using one or more of the host as network bits. Two very important factors that will lead to the determination of IP address block with a subnet mask are number of subnets required and the maximum number of hosts needed per subnet. There is an inverse relation between the numbers of subnets and the number of hosts. The more bits that are borrowed to create subnets, the fewer host bits are available. Therefore, there are fewer hosts for subnets. Chapter 9. Transport Layer. A transport layer provides transport-related service by dividing data received for an application into segments, adding a header to identify and manage each segment, using a header formation to reassemble a segment back into application data, passing the assembled data and correct application. UDP and TCP are common transport layer protocols. UDP datagram and TCP segments have headers added in front of data that include source ports numbers and destination port number. TCP does not pass any data to the network until it knows the destination is ready to receive it. If the application data needed to be delivered across the network quickly, or if the network bandwidth cannot support the overhead of control messages being exchanged between the source and the destination system, UDP would be the developer's preferred transport layer protocol. UDP provides none of the TCP reliability feature. However, this does not necessarily mean that the communication itself is unreliable. There are many mechanisms in the application layer protocols and services that process lost or delayed datagram if the application has these requirements. Chapter 10. Application Layer. The application layer is responsible for directly accessing the underlying processes that manage and deliver communication of the human network. This layer serves as the source and destination of communication across data network. The application layer services and protocols enable users to interact with the data network in a way that is meaningful and effective. Applications are computer programs in which the user interacts and manipulates the data transfer processes and the user request. Services are background programs that provide the connection between the application layer and the lower layer of the networking models. Protocols provide the structure of agreed upon rules and processes that ensure services running on one particular device can send and receive data from a range of different network devices. Protocols like HTTP, for example, supports the delivery of web pages to end devices. SMTP, IMAP, and PAP support sending and receiving email. SMB and FTP enables users to share files. P2P applications make it easier for consumers to seamlessly share media in a distributed fashion. All of these elements work together at the application layer. The application layers enable users to work and play over the internet. Chapter 11. Build a small network. Up to this point in this course, we have considered services that data network can provide to the human network. So, Chapter 11, Build a small network. In order to meet the user's requirements. Even small networks requires planning and design. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. An important part of the network design is reliability, scalability, and availability. Supporting and growing small networks requires being familiar with the protocols and network application running over the network. Protocols analyzers enable a network professional to quickly compile statistical information about the traffic flows on the network. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic, as well as the type of the traffic being sent. This analysis can be used by a network technician to make decisions on how to manage the traffic more efficiently. Common network protocols include DNS, Telnet, SMTP, POP, DHCP, HTTP, and FTP. After a network has been implemented, a network administrator must be able to monitor and maintain network connectivity. There are several commands available towards this end. For testing network connectivity to local and remote destination, commands such as ping and telnet traceroute are commonly used. Cisco IOS configuration files such as startup config and running configuration should be achieved. These files can be saved or text file is stored in a TFTP server. Some models of routers also use a USB port, and a file can be backed up to a USB drive. If needed, these files can be copied to a router or a switch from a UTP server or TFTP server or USB drive. So that's all for chapter summaries of chapter 1 to 11. Thank you.